Oh, snap. We're seeing this symbol, which is an integral. This is the third topic, guys. And you're like, what do you mean? Well, what letter does this kind of look like? What letter? Kind of looks like an S, right? And guess what? What have we been doing with those rectangles? We've been doing what with those rectangles to find the area under the curve? We've been adding those areas of the rectangle up. We've been summing those areas of the rectangles up. So this is just a fancy summation symbol, and you can see that this is where it's coming from. Again, we'll come back to that. It's not really hit on the AP much. I know that this is one thing, but it's like on one of 10. It's like once every 10 years they put a question on it. So I want to come back to it, but it's a summation, and all it is that summation. It's just an S really stretched out. And all that stands for is we're adding areas together. And again, we're just really focusing on those rectangles. And the rectangle has, when we were finding the areas of the rectangles, bloop, and if I were to do a left Riemann sum here, boop, 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 and then boop, 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 what was my base every time? It's that change on the x-axis, right? So my base, I technically could have written like delta x, change of my x, and instead of a delta x, they're just writing dx. That delta, they're making a d. So this is really the base of a rectangle, boop. The dx is really the base. And then how did we find the height? How did we find the height of my rectangles? It was just the value of the function. The value of the function, my f of x. So this right here is really the height. So all this is fancy notation of saying, oh, we're going to add up all of these base times heights, all of these rectangles from this x value to that x value. From A to B, it's saying from this x value to that x value. So this is just putting what we've done in the last 2 days in a fancy notation. This is saying we're just going to still find areas of rectangles, and we're going to add them up, or the area of anything under the shape, from this x to that x. And this is called an integral. Maybe just draw a little integral off the side. See how you do with your first integral. It's like an elongated S. So this question from 2013, we've done this topic, but we just haven't seen it asked like this. It says, what is the value of the area from 0 to 7 of the function? And you guys, so just let yourself know, oh, they're just asking for the area from 0 to 7. That's all that's saying. And could we break this up into different shapes? Might you see, oh, you're like, oh, there's a little rectangle, there's a little triangle, there's a little square and another triangle. You could do that. Or you might just be like, oh, I just see like one trapezoid on its side, and then another trapezoid that we're used to seeing, and then a triangle. Any way you want to break these up.
Trapezoid is just a rectangle.
How are we breaking these shapes up? I don't care, people. Do we want to do a trapezoid? I feel like you hate trapezoids. Yeah, you hate trapezoids. Okay, so let's go do a rectangle. What's this area of this rectangle? 2 times 1 is 2. What's the area of this red triangle? 1/2 base times height.
It's 1.
1, agreed. What's the area of this blue square?
4.
2 times 2 is 4. What about the area of this pink triangle? 1/2 base times height. 1. And then what about the area of this triangle down here?
I think it's 2.
It is 2, but since it's beneath the x-axis, what do we need to do to that?
Negative.
Yeah. So you guys, we just need to subtract that area being underneath it. You guys, let's add these up. 4, 5, 6, 7, 8 minus 2 is 6. Are they ready for you to add those two? Mm-hmm. Yeah. This symbol, you're going to see it a lot, and it's just saying find the area. This is saying, oh, go find that area from 2 to 12. You guys, it's always the area to the nearest x-axis. So this one's a little weird because we got to find this area. Got to find this area. Oh, yeah. It always has to touch the nearest x-axis. So it's either going to go down to the nearest x-axis or up. It says the graph of f of x contains a semicircle. Let's talk about some negative areas again, shall we? Is that what, yeah? All right, he's saying, I'm seeing this big old rectangle, and I can easily go find the area of a rectangle. I agree there, Ritzman. And then you're saying, what can we do with this semicircle? And you're like, I could find the area of a semicircle and then take it away. I dig it. Let's go with rectangle. I'm going to say rectangle, and I'm going to draw myself a little key up here. What's the area of this rectangle going to be? What times what?
It's going to be 6 by 10.
6 by 10. And where is this? Above or below the x-axis?
Below, so it has to be negative.
Below, so it needs to be negative 60. And listen to what Ritzy, you said, that we need to do rectangle minus semicircle. Stick with that regardless of the signs that we have. Do you agree that area of my rectangle would be negative 60? Yeah? Okay. What about the area of my semicircle? Will that be positive or negative?
Positive. Well,
I know it's underneath that x-axis though, so it's going to be negative. It's kind of funky. So let's just do my semicircle. My red semicircle. Anyone remember the area of a full circle is pi r squared? So I would just say pi r squared over 2, or 1/2 pi r squared. What is my radius?
it'd be 5.
Yeah, because the whole thing from 2 to 12 would be 10. My diameter would be 10, so half of that would be 5. I dig that. Pi times 5 squared over 2, but I am going to make that negative because, again, it's beneath that x-axis. Are we cool with just saying that's negative 25 pi over 2? You could say negative 12.5, but what's the diff? So I was focusing on these negatives because look at these two answers. Which one is it going to be? Stick with what Ritzy said. Rectangle minus semicircle. Right? Yep. See? Exactly. You're saying, okay, you said, Ritz, rectangle, which is negative 60, minus my semicircle, so minus that negative 25 pi over 2, minus the negative just makes a big old plus. And there it is. Oh, this is kind of funky. This one, again, they're just asking for the area from 1 to 5, but they didn't give us a picture this time. But we could kind of draw a picture, you guys. If we've got y equals 2, what does y equals 2 look like on a graph? Horizontal line. So I'm going to be like, all right, if y is 2, we have a y equals 2. And they have that when my x is less than 3. So I'm going to go 1, 2, 3. And my function exists till there. Where do they want that area, though? From what x to what x? 1 to 5. So I'm actually going to get rid of this. I only want this starting at 1. I want this starting at 1. What would that area be? Wouldn't that little area be, because we would go from 1 to 3, that's 2 by 2. The area of this guy's 4. Okay, so I can at least get rid of A. Then we're going to need to add to that this area from x minus 1. X minus 1. If I were to graph x minus 1, if I were to go down 1, then up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And where do we care about that? We have from 3 and to the right. From 3 and to the right. But they only care about that to 5. They only care about it to 5. So I only need to go to 5. And that's going to create from 3 to 5. I'm sorry, yeah, from 3 to 5. We then need the area of this red trapezoid. You could do a little triangle and a little square. But let's just do a trapezoid because we practiced those yesterday. If this trapezoid was on side, I might see it a little better. If it was on its side, I might see it a little better. What would one of the bases be? What would this base here be?
2.
2, because that was the height. I agree. So one of my bases is 2. Plus, what would my other black base be over here?
4.
Agreed. Those are my bases. And the formula is 1/2 the bases times the height. We started at 3 and we went to 5, though, didn't we? From 3 to 5. So that's going to be 2. My half and my 2 cancel out. Yes, ma'am. So the area of this trapezoid is 6. The area of that trapezoid is 6. When we add those together,
10.
we get 10. Whoops. All right. This question now says, lots of symbols. Woo. Which of the following expresses the relationship between? This is just talking about the area from 0 to 2. All we know about the area from 0 to 2 is it's positive or negative. Positive. Very good. The area from 0 to 2 is positive. So I might just do this off to the side. Area from 0 to 2 is positive. What about the area from 0 to 3? Because that's the next thing that they have right here. Positive, less positive, or negative? Yeah, less positive, right? It still has more blue above than red below. So I might say the area from 0 to 3 is just, I'm going to say a little less positive than the one before us. And then the last thing I asked, what about the area from 2 to 3?
That's negative.
Exactly, because it's below the x-axis. So they said, which of the following express the relationship? Which one is the smallest? Because they go, this is less than that, which is less than that. Which is the smallest? 2 to 3 is the smallest. Good. And you're right, Ritzy, we always read it from bottom to top, lower bound to upper bound. 2 to 3. And then what's the next bigger? 0 to 3. Whew. This is a free response. And we're talking parts A, B, and C. This is good. We're learning so much that we're ready for like full free response questions. Johanna. Has anyone ever met a Johanna? I have a friend named Johanna, actually. She jogs along a straight path. You know what we do in calculus? We move forward and backwards. That's it. She's jogging along a straight path. Her velocity is given in this table. Select values of her velocity are given. Meters per minute are the units. Okay. This goes back. You guys, this has nothing to do. This goes back to unit 2. If they said estimate V prime of 16. If here's V, how do I find V prime of 16?
You try to average the slope.
Changing y over changing x. Find that slope. I love it. 16 would have been about here. So let's go use these 2 points. What minus what over what minus what? Yes, sir. And I know you guys could all say 40 over 8. Don't do it. Don't do it. Boom. We are moving. Let's go do B, because now B, we see the symbol, and this is what we just learned about. Using the correct units, explain the meaning of this, and then approximate it. Oh my gosh, using a right Riemann sum. Oh my goodness, here we go. Okay, let's first talk about, let's do the approximation actually, then we'll do the units. Okay, this is again saying find the area from 0 to 40. Here are my x values, here's 0 to 40. Find the area. And they're saying using a right Riemann sum, this is a good practice. Area using a right Riemann sum. But what do you think these absolute values are going to do? Because it says absolute value of V of t right there. What does that mean we should do with all of our velocities?
Add them all together.
Well, that's what the integral says. What is the absolute value doing? Making all my velocities positive. If Macy is running around the track, when Macy's running north, I'm going to say her velocity is positive, and south, her velocity is negative. So your displacement would have been 0. And you're like, wait, I just ran 8 miles around the track. I want some credit for it. If we made all your velocities positive, we'd be giving you credit for all those laps. So, did they give us some negative velocities that we could make positive? They give us 1 there, right? Okay, so let's practice a right Riemann sum. This is a good reminder from earlier this week. A right Riemann sum, it says with 4 subintervals. That just means 4 rectangles. A Riemann sum is base times height. Sorry, the area of a rectangle is base times height. What's my first base? 12. What is the right height if I'm deciding between 0 and 200? Yeah, you pick the one that's on the right. In a right Riemann sum, I don't use the left height. So 12 times 200. What's my next base? 8 times 240. And next base? 4 times, be careful, it's absolute value. 220, positive 220. And 16, that's a very long base, times the height, 150. Here's the annoying part for this one, you guys. This is question 3. Only 1 and 2 are you allowed to have a graphing calculator, or a calculator at all. So we would leave our answer like this, right? The 7/8 rule. If you get 7 of the 8 of these right, you'll still get the point. But, so this is great for the right Riemann sum, but then they want us to explain the meaning. Oh, actually, we don't need the answer to explain the meaning of this. What is this doing? Yes. Is it the distance traveled, or is it the total distance traveled? We want to use the word total because they want absolute value, and they're giving her credit for all of her negative velocities, meaning just running backwards. So we're going to say, boop, 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 practice your little integral sign. I'll blow mine up a little bit. The integral, boop, from 0 to 40, absolute value, v of t, dt, is the total distance traveled in, because it says use correct units. What would her units have been? Don't forget, we took this times that.
It'd just be meters.
Yeah, we took minutes times meters per minute. And so those minutes are going to cancel, and I'll just be left with meters. So is the total distance traveled in meters, or you could have said the total meters traveled, my bad. Total distance traveled in meters from when to when?
0 minutes to 40 minutes.
Perfect. Thank you for specifying minutes as well. 0 to 40 minutes. Love it. Yeah. If Bob's velocity is this, what do I need to do to that to get his acceleration? Take a derivative. You guys have got it. I'm going to call that the acceleration b prime of t. What would the derivative of t cubed be? 3t squared minus 12t. Hey, Bob, we want your acceleration at t equals 5. Let's go plug it in. Let's go see what you were accelerating at. B prime of 5 then is 3 times 5 squared minus 12 times 5. Do we need to take it any further?
No.
Psh, Bob, we don't even care. That's your answer. Here we go. Height of water in a storage tank is given. And okay, this is perfect review. Tangent line. How do we write a tangent line? We need a blank and a blank. An x and a y, a point, and a slope. When they say use a tangent line, we got to go write this. We need to write that. They said use the tangent line when t is 2. There's some info given. Do you guys see any info about what the point would be? 2 comma what? Okay, what would be my point 3? Yeah, that's my slope, right? So I'm going to say my slope is going to be 0.3. Agreed. When t was 2, my slope was 0.3. When t is 2, what's the point? They gave it in our writing. I didn't even read this for you. Yeah, exactly. It's concave up. They give us all this info. At t equals 2, the height is 7. So there's my point. 2, 7. Let's go write my point slope form. Y minus 7 equals my slope of 0.3 x minus 2. They said use that tangent line that you just did. You got a point for writing that to estimate h of 2.8. Where am I going to put that 2.8? That's an x value. Like picture f of x, f of 2.8. That's going to go right there to find the height. You guys just get that y by itself. So I'd say y would be about, you could do an equal sign, that's okay. 0.3 times 2.8 minus 2. I'm going to bring that 7 over. That's my approximation. They're giving me a point for pink and they're giving me a point for black. Then they asked, is that approximation going to be an over or an underestimate? Give a reason. Here's the deal. Check this out. They did give us some info and I feel like I just didn't read this to you. The graph is concave up. If my graph is concave up, a tangent line will always be above or below my function. If it's concave up, isn't my tangent line always going to be underneath it? So therefore, this is going to be a underestimate. So it says, is the approximation, let's go ahead and say approximation is underestimate because the function which was, it says h, because h is concave up. So it says use a right Riemann sum with 5 subintervals to find the area from 2 to 14. Is that going to use all of our data in the table, 2 to 14? Sometimes they change these bounds and they might say from 2 to 10. And we just have to mind okay, we would stop there then. But this is saying go from 2 to 14. Sound good? Yeah. Ookie, what's the base of my first rectangle? 2. 2 to 4 is 2. Actually, I might even just go label all my bases to begin with. 4 to 5, 1. 5 to 8, 3, 8 to 10, 2, 10 to 14, 4. Just so they're like staring me in the face. You know what I'm saying? And then a right Riemann sum. Am I going to cross off 0.3 or 7.7? Very good. 0.3 is gone. Let's go find the area. Base times height plus base times height plus base times height plus base times height plus base times height. Gross. Boom, 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 boom. 5 rectangles. Sheesh. Just making sure I got my numbers right. 2, 1, 3. Okay. Don't solve it, but we do need to give units. Don't forget, we just took hours times feet per hour. Hours times feet per hour,
It'd be feet.
and we'd get feet. So that would be my final answer.